Good afternoon, everyone, and welcome to this, our final event in our Discovery Day at Home, or Discovery Days at Home. The whole weekend has been a science weekend brought to you from Dr. Jenner's House, Museum and Garden here in Gloucestershire, but broadcasting around the world, such is the magic of the internet. It's been fantastic to spend some time with you this afternoon, over the past couple of days, to talk more about science, to bring the event that we normally hold in the garden at Dr. Jenner's house to you wherever you are. And I'm really delighted for this final event that it's something that we've got, kind of bringing a bit of the museum to you, but also allowing you to take part and to send in your own photos. So thank you so much to everyone throughout the week who has contributed photos for our panel this afternoon to comment on. We're going to put them all up on the screen, but if you want to take a look at them later or have a look in more detail, you can go to jennermuseum.com/cloudspotting. If you want to send in any last minute pictures of clouds, I'm conscious here in Berkeley there are not many clouds at all, but I'm sure that our panel will talk more about that in a little bit as well. But if you have got any clouds that you want to send in for discussion, do send them to us via email, info@edwardjenner.co.uk, or you can do so on Twitter at Dr. Jenner's House, or Facebook, where we're Dr. Jenner's House, Museum and Garden. I'm really delighted to welcome Professor Giles Harrison, Simon King and Dr. Claire Ryder to talk more about clouds this afternoon. It's not an area that I know anything about in particular, so I'm going to leave you in their very capable hands, but I hope you have a really enjoyable session. If you've got any problems or you want to ask any questions, hopefully you'll ask questions rather than have problems, do put them in the chat box on YouTube and we will feed them to the panel.
Lovely, thank you very much, Owen, and very glad to be here to think about clouds. I did a walk around Berkeley last year in a very clear blue sky, and I think it's a very clear blue sky in Berkeley again at the moment. So this is the obvious way of getting rid of clouds, is to have a cloud walk around Berkeley. So I'm very glad to have Claire Ryder, my colleague from Reading, and Simon King, a BBC presenter, but also an alumnus of our department at Reading, to talk about clouds and the various aspects of them and the pictures that we've had sent in. So can we go to the first slide, please, Owen, and we'll have a look at one of the cloud pictures that's come in. So what have we got? I'd like to move on to the first slide rather than endure my own views of clouds from Berkeley. Thank you. So this is the Chantry, which is Dr. Jenner's house and garden in Berkeley, where Edward Jenner lived and worked. And so this is an image taken from the garden looking across the house. So that's a pretty splendid view of a partially cloudy day. Simon, do you want to pick up on what you see in those clouds?
Yeah, it looks like a lovely day there. So we've got some nice cumulus cloud there. It's quite thin cumulus, that cloud. So it tells me that the atmosphere is unstable. So that's why we've got convective cloud, but it's not that unstable. It's not got much height to those cumulus clouds. So they're going to flatten out a little bit. They're quite high up as well, those cumulus clouds.
So the cloud base is quite uniform as well, I think.
Yes, it is, yeah.
So that's what sort of height do you think the clouds would be at there? This is a guess, I know.
This is a guess, so I would probably say about 4,000, 5,000 feet, I would have thought. They're quite high, those ones. So cumulus cloud or convective cloud would kind of go up to height around about 6,500 feet. Anything above that, you could have then talking about altocumulus cloud, the medium level cloud. So they're quite high clouds, those ones. So it also tells me that it was quite a warm and a dry day as well. So the dew point and the air temperature have been quite far apart. So the humidity wouldn't have been particularly great on that day. And that's a good way actually of, if you can get access to air temperature and dew point temperature, if you want to estimate the height of cumulus clouds. When I was observing for the Royal Air Force, a great little tip that we had was to take the difference between the air temperature and the dew point temperature, times it by 400, and that will give you the rough estimate.
Which is great if you know how to get the dew point temperature. So So how do you suggest people can get the dew point temperature at home easily?
Home easily. Well, I would go to if you can have access to any sort of weather observations. And I guess dew point isn't one that you'd see a lot of. Obviously, on a lot of apps, you'd have, the air temperature. So dew point temperature, you'd have to probably go to a bit more specialist kind of meteorological sites to get the dew point temperature. But if you go to I don't know, there's a lot of aircraft specific weather sites would have the dew point temperature reported on those ones.
Or you could measure it if you have a thermometer and you have a wet bulb thermometer. So 2 thermometers set up then. And this is me advertising my book on measurements and instruments. If people want to know how to do that, then there's a perfectly good book available. Claire, I know there's been some smoke over Reading this week. Do you think there are any signs of any dust or aerosol in this picture?
So yes, you're right. We have had a lot of smoke in the atmosphere this week. Very interesting scenario, actually, because I'm sure lots of people will have known that there's very, very large wildfires down the west coast of the US at the moment. And they've actually produced such a volume of smoke that smoke is being carried by the atmosphere and the prevailing winds all the way across the US and all the way across the Atlantic, sort of being wrapped around weather systems and those high altitude winds. And we've actually had a lot of smoke above the UK and above Europe for the past 2 weeks, I would say. So it's pretty difficult to tell whether there's any contribution from that in this particular photo. Maybe we'll come back to that in a few more photos as we go through them.
Okay, well, we probably have dissected this one reasonably well. And if we spend this long on each photo, then it will probably take some time. So perhaps we should move on. So this picture, this is a rather different skyscape. And of course, this is not a Berkeley. I think we can conclude that. And it's rather a more it's a sort of lower cloud base, I think, and obviously broken cloud, and probably later in the day. I'm not entirely sure about that, but we can see a bit more structure, I think, in that cloud. Does either of you want to say a little bit about the cloud base and the differences in the cloud base, perhaps over land, over sea here? You can see perhaps a bit of rain in the distance as well. Simon?
Yeah, so this, you're absolutely right. It looks to me like it's going to later in the day. The sun's a bit lower on the horizon. The cloud base here is lower, much lower than the previous picture. So again, estimating probably 1,500, maybe 2,000 feet above ground level. And yet as well, you can see a much more structure in the cumulus cloud. And one thing that, again, quite a lot of people ask me about clouds is, why does some appear white and some appear very dark? And this is a great example, actually, because you can see the side of that cloud there, which is very bright. And obviously the sun is to the right of this picture here, shining on that. So that will, because the sun is emitting white light. So as the sun hits water vapor, water droplets in the sky, it gets scattered all over the place. And it's something we might touch on a bit later on about blue skies, but the whiteness is obviously the clouds, the sunlight is bouncing off the water droplets of that cloud and just seeing the white light. But then further into the cloud and why it's darker is that because obviously the sunlight has to go through a lot more of the water droplets, which is getting scattered a lot more. So then the darker clouds, obviously you're getting much less light going through to that point of the cloud, and that's why it appears darker.
So these optical effects really, I think, make the difference between a remarkably dramatic sky and quite a light sky. But also there is some blue sky in this as well. So Claire, you study how light interacts with things in the atmosphere, with dust and with droplets. Do you want to say a bit about why the sky is blue?
People often ask why the sky is blue, and it's a fairly straightforward answer. The reason is that the sun does contain light of different wavelengths in the light that it sends down towards us. And when there's no clouds in the atmosphere, mostly we've got small gas molecules above us in the atmosphere. And the thing that's important in this case is that those molecules are very, very much smaller than the wavelength of light coming down through the atmosphere. And so we get into a particular kind of regime there called Rayleigh scattering, which determines how different light wavelengths get scattered. And in this particular regime, the smaller wavelengths of light get scattered the most. So in our sun spectrum, the visible wavelengths of light go through from blue with the shortest wavelengths through to sort of green and then through to reds. And it's those blue wavelengths of light which have the shortest wavelength of light, and those get scattered most effectively when we have no clouds. So that is why the sky appears blue. The red and the greens are scattered, but not so effectively as those blue wavelengths.
So that really the different constituents of the atmosphere, the molecules and the dust and the droplets, they're all getting bigger in size. So we've really got a wide range of things of different sizes, and the light is much, I mean, doesn't vary anything like as much in its wavelength.
Yeah, so when we're looking at bigger particles in the air, like cloud droplets, or something that's perhaps not quite as big, such as a smoke particle or a dust particle in the air, they're all scattered in slightly different ways, and that controls how the light reaches our eyes and the kind of colours we see, and the different optical effects we get from looking at the sky, and really make it quite fascinating to look at.
Good. Well, I don't think we've got a rainbow, unfortunately, which is really the ultimate optical effect. But let's move on, please, Owen. Let's have our next photo. Okay, so you were mentioning, Simon, dark clouds and light clouds. And so we've got something looking a bit more like a dark cloud. Can you say some things about a storm cloud?
Well, this is so this is a great one as well. Look, you can see the shadow there of the chimney onto the bottom left-hand side there. That's a great example that we've obviously got some blue skies, we've got some sunshine somewhere, but then this massive cloud here. So it's very difficult to tell exactly how thick this cloud is because we can't see the top of it, but it's likely that it's a very thick cumulus cloud verging on a cumulonimbus cloud, which is the mother of all clouds.
The ultimate storm cloud. Yes.
The storm cloud, yeah, exactly. So the very fact that this is quite a dark cloud, it's telling you that it's very thick. It's probably going to rain pretty soon, I would say, as well, just looking at that cloud.
And do you think rain or do you think hail?
Well, quite easily it could be both. I mean, yeah, absolutely. So we've had some hail this week, actually. I don't know if anyone saw pictures from West Yorkshire, Bradford, around Gloucestershire as well. Actually, there was some hail reported this week. And so what's going on inside this cloud then? Let's just have a look, describe that really. So we've got these big updrafts which are causing the air to rise up really quite quickly. It's cooling, it's condensing, and that's why we get a cloud in the first place. But we've got quite violent updrafts, and the cloud is growing and growing and growing. It's got a lot of energy in the atmosphere to produce these cumulonimbus clouds. So it can go 3 to 4, 5 miles high up in the sky, and it's like a big washing machine. So within it, you've got the updrafts and the downdrafts. They're very powerful. And at the bottom of the cloud, it's going to be warm enough that it's going to be water droplets. But then as these water droplets get higher in the sky, they're going to be turning to ice. So the water droplets will freeze, and then the ice will get bigger, and then eventually the gravity will take over the updrafts, and it will come back down to the bottom of the cloud. But then it will get picked up by more updrafts, and it'll go back up into the clouds. The whole process continues, and the ice crystals can turn much bigger, so they get layered up. So if you actually split a bit of hail in half, it looks like an onion because it's got layer upon layer of this ice, until eventually it gets so heavy that it will just fall to the ground. So hail is actually more common really in summer and early autumn storms. People think of hail.
And
as
what about the consistency of the hail? Because the hails can be quite a fluffy, snowy, soft hail, and it can be very metallic, very icy as well. And that, I think, is important for some of the other properties of the thunderstorms. That's a very vivid description of a thunderstorm, and clearly not a place to be, although there are accounts of people who have survived going through this meteorological washing machine, as you described it. And it's pretty bad. You get pelted with ice, and you get hypothermia, and you probably get burns from lightning, and it's pretty, it's a terrible place to be. And of course generates turbulence as well if you're if you're an aircraft. Claire, you've done a lot of aircraft work. Have you been in those sorts of situations?
Well, when I fly with my research aircraft, the pilots are always wanting to avoid these intense large cumulonimbus clouds because they're very dangerous to fly through. But I have seen them from the air, particularly off the west coast of Africa when I've been doing research into Saharan dust, and they are pretty phenomenal things. Yes, aircraft definitely want to steer clear of the worst of them.
Yeah, definitely. Should we move to the next picture, Owen, please? So we've got a different landscape here, and we've got again some cumulus clouds. One of the features of these are really fair weather cumulus clouds, and often indicators of fair weather, or they can grow and they can begin to fill the whole sky, and the fair weather can cease. And they have very characteristically even cloud bases. So you look at the heights of the bottom of the clouds, and they're quite similar across that particular landscape. Any indicators of any aerosol in that one, do you think, Claire?
Again, it's hard to see. It doesn't look like it's sort of sunrise or sunset, which is when you tend to see these effects. I noticed from the captions online, it says this one was taken in Dartmoor.
But of course, we know there must be aerosol in the air for the clouds to form at all.
That's right. Yeah. So actually, it does take tiny little particles in the atmosphere of dust or similar types of material, really, really tiny things, smaller than a grain of sand, which actually allow the cloud particles to form in the first place. And if it wasn't for these, then it would be much, much harder for clouds to form in our atmosphere.
And there's always an abundance of these particles, so clouds can always form, but it's...
That's right. What gets interesting is when as humans or as natural events like dust storms or wildfires or pollution, if it's man-made, increase these numbers of particles in the atmosphere, then how that goes on to potentially affect clouds. And it can affect clouds in many different ways, such as increasing the number of cloud particles, potentially making the clouds last longer or allowing rain to form more quickly. And it's really very much ongoing area of research.
Yes, so it really changes what the clouds do in terms of how sunlight passes through and how they let the heat from the Earth out again as well. So the properties of the clouds really determine the properties of the atmosphere around it as well. So there's a lot that goes on there, everyday things, but they're incredibly intricate in terms of the processes that are happening. That's Simon, right. That looks like pretty well classic fair weather cloud landscape to me, I think. Is there anything else you want to add?
Yeah, no. These
you know that bit of Dartmoor?
No, I don't know that bit of Dartmoor. No, but this is classic Simpsons clouds. You know, if you ever watch The Simpsons and they have the cumulus clouds, this is what we'd call a Simpson landscape.
I don't think Luke Howard used that description.
No, perhaps not. No.
Well, clearly that needs to be revised and in next cloud atlas, I think, by the World Meteorological Organization. Should we move on to the next cloud? So there's a bit more happening at the higher levels there, I think, in terms of we've had a lot of low cloud with a lot of convection and very strong cauliflower cumulus clouds. Now we've got things happening a bit higher up, and we're not just dealing, I think, with liquid water in the clouds anymore. There's actually probably some ice present. What do you think about those upper level clouds, Simon?
Yeah, so these are cirrus clouds, and those are the very high level clouds. And as you said, exactly, these clouds are made of ice. So we're so high up in the atmosphere. We're talking now probably 30 to 40,000 feet high up in the atmosphere, where it will just be ice. There's no water up there at all. So that's why you can tell if it's ice, because it's got a much more kind of wispiness around it. It's much smoother kind of texture to it. So that's a telltale sign that they're high up clouds and they're ice clouds. And
it will have very different properties for passing and transmitting light, the ice crystals, compared with water droplets, Claire, won't it?
That's right. The ice clouds tend to be much thinner, so they tend to block light out much less effectively. So that's generally the dominant feature we see from ice clouds.
But also, I think they're characteristic of a change in the weather as well, in terms of what's going to happen. Quite often we see the cirrus in the first stages of a front passing through, and as a change in the weather, they're a very useful thing to look at. And sometimes you can see aircraft below as well, and you can see contrails at the same sort of height. What is often remarkable, if we can remember back to whenever we were flying, then it's very difficult to see cirrus from the window of an aircraft. You think, oh, there's lots of cirrus up there, and then you fly and you don't see it. I'm sure, Simon, you're going to give me an exception to that you've flown through and seen the ice forming on the windows, and that's perfectly normal in the RAF.
Yeah, no, exactly that. So the contrails, actually, it's an interesting part of the RAF. We had to forecast contrails. So again, how much ice and how much a trail an aircraft forms is very dependent on the humidity up at that level. So if it's not very humid, i.e. the air is very dry, then sometimes you might notice if a plane goes overhead, it might have a very small contrail. It kind of disappears very quickly, and that tells you that the air is very dry because the moisture is just being evaporated out into the atmosphere. Whereas if it's very moist, you would see those contrails sticking around for a lot longer. So as you can imagine, in the Royal Air Force, that's quite important to get right, because for purposes of these high-level reconnaissance missions, you don't want these big contrails.
Yes, saying this is where we are.
Being there, exactly.
Yes.
So that was quite important to forecast for those. Yeah.
I think there's a famous line on an early meteorological diagram from the Second World War, which said when a Spitfire would generate a contrail, I think it's there was a way of working that out, and it was again a very important thing to know about. Let's move on, please, Owen, to the next one. So this again is not in Gloucestershire, and
David's Pembrokeshire, it says.
I can't see the bottom line, so good. Thank you for prompting me on that. Do you want to talk about the reddening of the sky in that, Claire, please?
Yes. So this is our first one with a really nice red. I presume it's sunset rather than sunrise, but you never know. It could be either.
7:30, it says.
Oh, does it? Okay.
on the church clock.
The clock.
Oh,
it doesn't help us, of course. It's not a 24-hour clock.
No. Anyway, whatever it is, we can see those lovely oranges and reds coming out in the sky, and also in the clouds. You get some lovely colours when you get these broken up kind of alto cumulus type clouds and the layers of different clouds. And so what we're seeing is that as the sun gets lower in the sky, more of the sun's rays get blocked out by the atmosphere as the sun kind of has to travel through more of the atmosphere to reach us. So generally we tend to see more of these reds and oranges from the spectrum getting through compared to the blues. But particularly when we have lots of pollution or dust or smoke particles in the atmosphere, these are much larger than the gas molecules in the air. So they tend to interact much more with the visible light rays that we see, so that we see extra scattering of those longer wavelengths like the reds and the oranges, and less from the shorter wavelengths like the blue. So those longer wavelengths of red tend to reach our eyes more effectively, and that's what gives us these really lovely sunset and sunrise pictures. So that's really nice to see.
No, it's a very nice example.
I guess, isn't it, Giles, as well? It's the type of cloud as well that makes them really vivid. So if you've got this alto, the medium level clouds like this alto cumulus, alto stratus cloud, that can reflect, can't it? It can bounce the light off the bottom of the cloud, and that makes it really quite vivid. And that's why, if you have those clouds in the sky, they can get some really, really nice sunsets and sunrises.
Yeah, a lot of contrast in texture, really, isn't it, between the alto cumulus and the more stratiform cloud. Let's move on then. Let's go on to the next one. So this is a much busier sky, and we've been talking about the high-level cloud and the low-level cloud separately, and this one has brought it together. We've got some cumulus clouds and fairly fair weather cloud growing in the base, and then we've got some high-level ice cloud, and maybe I think also a contrail in the middle. You can just see the slight mixing that's going on along that track of that particular contrail. And I can't see where it is. Is there
Berkeley, Gloucestershire, it says.
So that's probably the 7 then, I think. And so what do you think, Simon, about this? Good day for flying?
Yeah, absolutely. That would be a great day for flying. Yeah, so those cumulus clouds, they're not going to cause you any issues at all. The aircraft, you'd be just darting in and out of those. What strikes me about this photo actually is how, we talked about it before, how uniform the base is, and you can really see how striking that is on this picture here, how all the cloud bases are, all the convective clouds, the cloud bases are all the same height. And yes, some lovely cirrus above that. Yes, it's a very nice day.
We've often put, one of the things I do is put balloons through clouds and measure them, and often the top is well defined and the base is quite ragged. And with fair weather cumulus clouds, then it's really the opposite is true, that the base can be very well defined and the upper part of the cloud can be really quite variable. You can see a bit of growth going on in those clouds. And the contrail, do we think the contrail is above or below the cirrus? It's a bit hard to be sure about that, but they're clearly comparable heights, I would think, but perhaps one is above the other.
Yeah, I think that contrail is probably below. Just the top part of it looks a little bit less icy, should we say? It looks a bit more alto, kind of altocumulusy sort of texture. So I'd say it's probably below.
Anything else, Claire, you want to add on that one?
Yeah, I just wanted to add that, this is quite a nice photo to see some of the different levels of cloud in the sky. Yeah. We can see the low cumulus and the higher cirrus type clouds. And I just wanted to say that the smoke that we know has been over the UK, or passing it in various pulses over the last week or so, probably would have been in kind of mid-levels between these low cumulus clouds and the high ice clouds higher up, that the smoke would have been between those two levels, so that it wouldn't have been down at ground level where you could have smelt it, but it's probably been up 3 to 5 kilometers high up in the atmosphere. So it's quite a nice photo for visualizing the kind of heights that would have been at.
I think it's very good. It's lovely with the river at the bottom and then the level of the clouds and then the level of the high clouds. It's a very nicely sort of stratified picture, if not a stratified atmosphere, in terms of the layers that are present. Let's go on then to the next slide. So we're back at Dr. Jenner's house and looking from the front of the house and up towards the Cotswold Hills, actually behind. So we've got again a more convective sky, but a lot of gaps in it, and we haven't. This is moving a bit beyond, I think, the fair weather that we've just seen. These clouds are beginning to develop. I don't know what time of day this was or how far through the week it was, but this is a more convective sky and lower level clouds. Do you have anything on that, Simon, you want to add?
Not particularly. No, it does look a lot more ragged, doesn't it? The cloud bases don't appear to all be the same height. You could pick out a few more differences there. It looks something less uniform than some of the other pictures that we've seen.
It is, I think. Claire, is there anything you can see in that one?
No, nothing to add really.
No, I think so. So it's but just think about the variety that we've seen looking over Dr. Jenner's house already. Every skyscape has been different that we've seen with the house and the pictures. So it's good to be reminded just how every sky is pretty unique when you look at it. Let's go on again, Zoe. So this is also, I think, Berkeley.
Berkeley, yeah.
Yes. And so we've got really a sky which is half clear and clouds advancing, I think, or possibly retreating, probably advancing. I think this is, if I'm right, this is going east, west, right, left to right here, I think. So we're seeing some probably deeper clouds. I think we can be reasonably confident about that. There's less high cloud present, and again, quite a well-defined cloud base, actually, I think, in this. What do you think, Simon?
Yeah, it kind of reminds me a little bit of it's it kind of, when I see that picture, it kind of reminds me of sort of a day where you've had quite a lot of cumulus developing actually throughout the day, because you've got the heat of the day, and obviously that's why cumulus clouds form, because the sun is heating the ground. That warmer air is then rising, cooling, condensing. So that's why you get these cumulus clouds building up, from 10, 11 o'clock in the morning, on a classic kind of cumulus day I'm talking about here. And then as it gets into the evening all the time, you lose that heat, so they kind of start to fade away. So this looks to me like it's towards the end of the day,
and they're dissipating,
and they're perhaps starting to dissipate. But of course, it's very difficult to tell from just one picture, one snapshot of what's going on. So, but that would, because obviously there's a lot of blue sky, and in the background there is a little bit of higher cloud, I'd suggest as well, just to the right of the picture.
I haven't got that bit.
No. So,
but yes, so there is a bit more going on at higher levels. Claire, is there anything for you in that picture?
Yeah, talking about the higher levels, really. This photo strikes me as having a lot of fairly nice, lovely blue sky in it, which makes me think of sometimes when you get very strong northerly flow with lots of air coming in from the cold, clean Arctic, which we may have had a little bit of this week at some point. May have been one of those phases where we didn't have much smoke in, and you may notice sometimes if it's a very clean northerly flow, the sky can appear particularly noticeably blue, whereas often if it's very polluted, the sky almost has a white kind of feel to it. So we tend to see a lot of different colours in the sky, and there's actually a lot of reasons behind that.
And which is really the airflow we've got at the moment today, isn't it?
Yeah.
Certainly in Reading, and I think also in Gloucestershire as well. Okay, let's move on. I'm sure we've got plenty more to look at. So there is something in that for you, Claire, I think.
Yeah, so the caption says also Gloucestershire. Yeah, we've got another lovely sunset here, well, a sunset or sunrise. Lots of lovely colours again, reds and going through to oranges. And again, it's the sunset catching those clouds, which really gives it those lovely colours. So yeah, very nice to see. That's again because the sun's low in the sky, and we're getting scattering off those pollution or dust particles in the atmosphere, and then those rays of light catch the cloud.
And these are water droplet clouds. They're quite low clouds in terms of what we've been looking at.
Yeah,
that
grey cloud sort of towards the right looks particularly low.
Yes, I think it does. I can't really estimate the height. I mean, the trees are there. I can't see where the ground is, but yes, those are water clouds. Simon, can you see anything in it?
No, I mean, yeah, I just wanted to declare whether or not you think that if that was this week, whether that does have any of the California wildfire smoke in it, or not really. I don't know.
Yeah, so I've been looking at the satellite imagery, which is what allows me to see when the smoke has arrived and when it's been present and over which parts of the country. I don't know which day this photo was taken on, but almost every day, I think apart from one this week, some part of the UK, particularly England and Southern Ireland, has had some smoke over us. So I would think it's fairly likely that the smoke was contributing, at least in some part, to the nice colours we're seeing here.
There's always something to watch for, isn't it? And it's often the first clue that the dust has arrived in the sunset beforehand. Let's move on, please, Owen. Okay, so this is a much smaller scale cell structure to these clouds. And you can see the fact that it's also obviously more broken. And is this a sunset as well, do you think, Claire?
Yeah, I mean, we've definitely got a low sun, I would say. Again, I can't tell whether it's sunset or sunrise. The caption says Gloucestershire.
We're strongly rooted in Gloucestershire for these pictures. I think that's all very appropriate for the Janno house.
We're seeing those oranges coming through towards the bottom of the photo where there's some more gaps in the cloud. And I think perhaps there's some thin cloud behind the sort of alto cumulus we can see towards the front.
So we're looking through this lower level of cloud. to the upper cloud. We can just about pick it out, I think.
Yeah. So it's less intense because there's some fairly thickish cloud around, but you're still seeing those sunset colours coming through.
I was wondering if there was a hint of colour in the ice cloud in the gap, about halfway down on the right-hand side. But maybe I'm imagining that. It's probably isn't there. What do you think, Simon, about that particular view?
No, yeah, just all the same, really. Yeah, you can see the high-level cloud behind this. Again, you can't see the horizon, so it's quite difficult to tell exactly how high this would be, but it's certainly high-level stratocumulus, low outer cumulus cloud, and just that milkiness. That, again, you can tell the higher clouds just because the milkiness behind it. And sometimes, when we talk about in the weather forecast, then making the sunshine hazy or a bit milky, that's classic kind of speak really off that there's a lot of this high level icy cloud in the sky, or just kind of making the sky that whitish milkiness.
And that would be when you mentioned the persistent contrails earlier, that the contrails would stay around, and that would be when they would do that as well.
Yeah, absolutely. Yeah, the contrails would just spread out, wouldn't they? If you get lots of them, you'll end up with quite a large chunk of the sky covered in the contrail.
Let's go on to our next photo then. So this is a very, I think, fair weather cloud again, and we're looking at a slightly different angle. We're looking up towards. This is Gloucestershire again, I think, and we're looking up a hill, and we're seeing some cloud around the top, and it's a very sort of less than half of the cloud is covering the skies overall. So this is probably a fair weather cloud that's not developing, but it's less obvious in terms of its structure, in terms of its base, and the upper part of the cloud than the sort of streets of cloud that we were seeing earlier. I think that's possibly part of the viewing angle, really, as well as the nature of what's there. What do you think about it, Simon?
Yeah, you're right. It's difficult to tell. Again, it's quite ragged, but again, the beauty about convective cloud is that they all form in completely different ways. No two clouds are going to be the same, and even though the setup for this scene is very similar to other pictures that we've had, it just proves that you can get completely different cloudscapes, seemingly from the same setup. So you've got some very small cumulus clouds, little puffs of them here, there, and everywhere. So again, it tells me it's pretty quite dry up there. You've got some convection going on, some condensation, but then evaporation happening fairly quickly. I don't think these clouds would last very long. They'd be changing all the time.
But this is also one of the reasons why forecasting where showers are going to happen is really difficult, because this is exactly what's happening with showers, that the setup, as you say, is the same, but exactly what develops where is extremely difficult to be able to be sure about.
Yeah.
Claire, have you got anything? Sorry.
Welcome. No.
Yeah, just lovely vivid colours there. Nice blue sky and lovely bright green grass. Probably had some good rain in the last few days to make it look those bright colours.
So we haven't said that much about what comes out of clouds, have we, really? There's been few examples of that. But Simon did mention the different types of hail, and of course, if we thought a bit further, clearly, depending on the time of year, we could get other forms of hydrometeors, I would call them, but snow, rain, and hail. And this particular kind of hail that I'm interested in, the soft hail, the slightly fluffy hail, because it's strongly associated with lightning and the development of electrical processes in clouds. This particular day would be one in which I could still measure electricity in the atmosphere, because I know that electricity is always present, even on days when there aren't thunderstorms. But it is something where, with those particularly convective clouds, then we can get very strong cloud electricity. Maybe I'll get a better example to talk about that on later. This is not the one really to discuss lightning with, but I just thought I'd mention that there is electricity present in this one as well. Owen, should we move on? I wonder if that's around the same time. and around the same place. Is this perhaps the,
Yes,
the
the
similar
captain
hill?
for both of these says Dursley, Gloucestershire.
Okay, so I wonder if that's a similar hill from the other side. But again, the characteristic that we saw from the previous one was the raggedness in the cloud base, where previously we've seen quite a lot of very well-defined cloud base heights, and these are rather more ragged. And then, of course, the upper part of the cloud is there's much more variation from one cloud to the next. But overall, I think less than half the sky covered, so pretty well a fair weather situation. And as you say, well green, well watered grass, Claire. Anything else you think in that, Claire?
No, nothing from me.
Simon, nothing? Okay.
No, no.
Let's move on. We're really dealing with fair weather cumulus here, and really got a lot of those. Okay. I can't see the
Also
base of this
says
one.
Dursley, Gloucestershire.
We're doing well for Dursley, and so perhaps this is.
It seems to me that one of the first ones we had of the hill was quite early on in the day. You know, you had very small.
Simon, you've frozen, I'm afraid. We seem to have something's not updating properly. I don't think it's just my internet. Claire, are you?
No, I'm not seeing Simon either at the moment. He's frozen for me.
Right. Well, I mean, I think he was going to say that this is probably later in the day, and I think this is perhaps where the same clouds are dissipating, and we're beginning to see what was perhaps a bit more cloud, perhaps a little bit higher here, spreading out and dissipating, and much less a lower fraction of the sky that's covered. I think it's probably the same region. Are you seeing anything else there, Claire? That's
yeah. So if we look towards the
distance,
horizon here,
yeah.
because we can see quite a long distance in this image, and you sort of contrast the color of the sky down by where the horizon starts, right up to the top of the photo. You can see a lovely gradation in the colors going from blues at the top, and then you can see it kind of starts to get a darky, slightly murky grayish brown with maybe a hint of reddy brown into it. So this is basically due to particles in the atmosphere, and you begin to see this effect probably because this photo is later on in the day, and you begin to get the extra scattering through these particles. So you can almost get an idea of the height of which we tend to have pollution in the atmosphere, and this photo does a nice job of illustrating that.
Do you think we can estimate anything about how high that dust is, or is it difficult to do it? I mean, the cloud in the foreground and the dust perhaps in the background are a bit confusing from that point of view.
Yeah, it is. I mean, if it was sort of local pollution, usually we see it kind of up to the start of where the height where clouds begin to form at about, say, 1 kilometer high. If it's more long range, long transported pollution, it tends to be much higher up in the atmosphere in order to get transported these long distances. And given that we know there was probably smoke in the atmosphere, it is quite hard to say from this particular photo, actually.
But there's certainly the hint, as you say, at the horizon of something present there. Should we move on then? Owen, can we go to the next picture, please?
Dursley, Gloucestershire again.
Right. So we're seeing again some fair weather cloud and well-defined cloud base. And this particular view, which is sort of looking down the hill, you can really see along the sort of the lower parts of the cloud, pretty good clear blue sky above. I can't see any high level cloud through that. And that gives us some clues. And I get the impression that was sort of afternoon. I don't know what you think about that, Claire.
Yeah, I think I'd go with that. I think we've got Simon back with us. We lost you for a minute.
Yes. Hello. I don't know what happened there.
We've got another picture from Dursley of fair weather cumulus clouds. And we were just thinking perhaps this is an afternoon picture as the clouds are a bit more developed. What do you think?
Yeah, absolutely. Yeah, it looks like the height, the thickness of the cloud is slightly more than it was previously. So, yeah, that would certainly tell me that there's more development there. There's more convection going on, and it's what I like about this cloud. This picture here is the nice little just darker cloud, the grey cloud, very contrasting with the white cloud behind it. So obviously that one, that little bit of the cloud is, is obviously in the shadow of another cloud somewhere.
No, there's a lot of structure in that picture actually. There's clearly a lot going on. Shall we move on, Owen, to the next one? Well, there is some cloud in this one, and it's again a cumulus cloud, maybe perhaps a little bit deeper, as you say, Simon. The varying grey and white in this cloud shows a bit of variation from one part of the picture to the other, and there's some blue sky behind it. I can't see in the blue sky any particular high cloud. Can you see anything else, Claire, in this one? No?
No, I mean, it's a nice photo. There's that grey cloud, lowish grey cloud around, blocking the light out. Not too much blue sky in this one.
Yes, and I think that's probably...
If I was observing on this particular day, I might suggest that there might be a shower or two maybe starting to develop somewhere.
Well, maybe we'll get a sequel picture a bit further on, and we'll see whether that's right or not. Should we move on, Owen, please? Now we're on to optical phenomena. You want to tell us about the rainbow, Claire?
Yeah, so we all know that this is a rainbow. We can see all the different colours there. One thing lots of people don't know is that if you're out and about spotting for a rainbow, and it is that kind of day where you've got lots of rain, cumulus clouds, and the sunshine still shining through, if you want to spot the rainbow, you should put your back to the sun, because the particular scattering pattern that forms a rainbow forms when rays from the sun shine and scatter through rain and cloud and then get bounced back towards you. So that's the best way to try and spot a rainbow.
And this is a single rainbow. I mean, sometimes you see a fainter rainbow a bit further out, or extremely rarely you might see two. They're called supernumerary rainbows, but they will appear different, won't they, to the in terms of the order of the colours in the first rainbow?
That's right. The inner rainbows usually will be reversed in the order of the colours. So whereas this rainbow here has the red on the outside, the secondary rainbow would have red on the inside.
Have you seen many supernumerary rainbows, Simon? You must have done.
Only via our weather watchers. So the BBC Weather Centre, we have the weather watchers. So I get to see a lot of photographs of clouds on a daily basis, actually. I go through lots of them. Yeah, and occasionally we've had some fantastic rainbow pictures of double rainbows, reflected rainbows, supernumerary rainbows as well, which are really quite rare. You could tell me more about that, probably, Claire, but yeah, we don't get them very often. I think one photograph, which was really quite remarkable, we had a supernumerary and a reflected rainbow all in one picture.
Wow!
So it was like a optical explosion going on the picture.
Fantastic. Yes. You really, I mean, you have to be lucky to see those things, but because of camera phones, then they can be captured now, and there's increased chances of people observing and recording rather than just spotting it. So there's a good chance that there'll be images, and that's really what's changed. I mean, you must both know the stories about Asperitas cloud and how the WMO classified a new cloud, the World Meteorological Organization, because eventually essentially the citizen science activity of people recording it meant that there was a lot of evidence that it was there and something was different. So the world of capturing atmospheric phenomena is very different to maybe 20 years ago in terms of things that we thought were unlikely. We now know how unlikely, or the fact that they're actually present. I think we should move on to the next slide, Simon. Owen, please. Okay, so this is a very different setup, and we've got some interesting crepuscular rays coming through the gaps in the cloud. probably later in the day, but hard to be sure. And do we know where this one is? Is this?
Yeah,
This
let me
is
see. Just catching up. Well, this isn't on the web feed, so I can't tell you, I'm afraid.
no, okay. But it's quite an overcast sky. Simon, do you want to say a few things about this one?
Yeah, it's a lovely photograph. Yeah, crepuscular rays, which is or God rays, as people know them as. And what I love about crepuscular rays, actually this week with our weather watchers, we had a lot of these actually sent in to us. And while they look like they are converging to one point behind the clouds, they're actually parallel. So it's an optical illusion. It's the same as if you're looking down a straight road, how it's wide where you're standing and then it can converge to a point of the distance. And that's what's going on with these rays, which is quite nice.
Also, it tells you a bit about the complexity of the atmosphere, because we've talked about the sun's rays shining through the sky or just being blocked out by a cloud, but actually it's really not that simple. You can often get sunlight that's scattered down the side of a cloud, or sunlight that partially gets through a cloud. And the sunlight and the Earth's energy can reach the surface of the Earth in many different complex ways. And that's also an ongoing area of research in weather forecast models of how exactly to represent the details of the radiation and the sunlight getting through our atmosphere.
So the silver lining effect is this effect of the sunlight being thrown away from a cloud, isn't it? Where you can end up with a great deal of extra sunlight. And this is just, as you say, the complexity of the setup of where the light is coming from, how it's transmitted, and how it ends up at the surface. But this is a very nice example of the crepuscular rays. Let's go on to the next one. So, do we know anything about when this was? But it's perhaps a dawn picture. Do we think?
It looks to me like a morning misty, foggy start to the day. Yeah.
Yeah, lovely photo of the sun just coming up or going down, whichever it is, shining through the atmosphere there. Fantastic colours.
So one of the things this week was some valley fog actually, which was forming down towards the River Severn, and that eventually lifted, but it took quite a lot of time. It was very established in the lower part of the valleys, and then it rose a bit, and then it really just became a layer of stratus cloud. And so I'm guessing this might be near Berkeley again, and that we might be down on the floodplain. This is quite flat, close to the River Severn, and perhaps this is what it is, with perhaps the hint of some distant hills. Anything else on this one? No, I think probably. I mean, it's very. I mean, I like these types of clouds for a lot of experiments that I do, but I think optically we've looked at it really carefully. Let's go on to the next one, please, Owen. So this is a non-cloud phenomenon, strictly speaking, I think, but there is some cloud. We got some nice, probably dissipating cloud again at middle level cloud, I think, liquid water cloud. What do we have to add on that? I mean, it's I think most of the things that we've talked about previously are really in this picture, or in terms of what's on the horizon, what's in terms of the blue sky, what's in terms of the convective clouds. Do we have anything else to add to that one, do you think?
Yeah, well, one thing I could probably add to that is from this picture, it looks like, so we've talked about how cumulus clouds just build and develop, and they can have different heights and thicknesses, and the point at which clouds will start to condense early in the morning is fairly low down, but then as the day gets warmer, the cloud bases go higher because the lifting condensation level, we'll call it, goes higher in the sky. And eventually, if you've got a day where there is maybe an inversion in the atmosphere, where a point at which the the temperature starts to warm and not cool. So what I'm getting from this is that the cloud has been building throughout the day. The cloud bases have got higher and higher, and it's hit this inversion at the top, and that's why they start to flatten out at the top, and eventually they'll dry out completely if the cloud lifting condensation level gets to the point at which the inversion is. You won't get any cloud forming at all. So this looks to me like at the end of a day, on a fairly warm day, and you've just got that kind of capping of the cloud. It's starting to spread out a little bit, and eventually it'll disappear.
And the long shadows perhaps hint at that as well. I think perhaps looking at the shadow casting canine that we've got in the foreground. Claire, is there anything else you want to say about this sky?
No, I think you guys have covered it all. But I just thought maybe we should say a bit about. I think this is our last photo.
It is, yeah. It's the last photo.
We've been asked to say a little bit about how people can get into weather and climate and meteorology and atmospheric science.
Well, there are a lot of things we could say about that, and we don't have another hour, but we could say some things. So the University of Reading has a meteorology department, which we've all three been at various points, and Claire and I are still at. And so we run meteorology degrees and undergraduate, postgraduate, and doctoral degrees in meteorology. But there are many other ways into meteorology as well. And as a subject, you can see it as a subject where there's a lot of space for amateurs. There's a Royal Meteorological Society people can join, and there's a Cloud Appreciation Society that I think is really something that should be mentioned given what we've been looking at today. There are other routes through. People can get careers in the Met Office, and that's something where that is a very international career in many ways, because the World Meteorological Organization, there are meteorologists really across the world. Everywhere with an international airport will have a meteorologist. Simon, you've worked in the Met Office, and so you could say a few things perhaps on that as well.
Yeah, well, yeah. So as you said, so I went through Reading, did an undergraduate and then a postgraduate degree at Reading, and then went straight to the Met Office, where I did a forecaster training course. So if you join as a forecaster, you then go, even though you've done 2 degrees in meteorology, then have another year of like specific weather forecaster training, which involves a lot of classroom work again, and then being posted out to an Air Force base, because a lot of forecasters actually in the Met Office. There's lots in Exeter, but there's a lot around the UK at the Royal Air Force bases. So I spent a lot of time there forecasting for the military, and I actually joined a unit called the Mobile Met Unit. So I became an officer in the Royal Air Force, and then I was posted out to Iraq and Afghanistan to provide weather forecasts for the military in those hostile environments, which was very, very interesting. People say, well, why do you need weather forecasters in the middle of a desert? But it's not hot and sunny there all the time. You can get some severe, yes. You can get severe thunderstorms, dust storms. So it's very interesting. Yeah, so it can take you to a lot of different places. Weather, and as Giles said, every airport around the world will have meteorologists.
It's a very international subject, and there's been international cooperation in meteorology for a very long time, integrating measurements and forecasting. This is something which is a very significant human endeavor, I think, for the last century or so. Claire, have you got anything else that you think we've missed on this?
I would say if anyone who thinks they might be interested, if you're still school age, then keep studying maths. Maths is the most important thing if you want to get into meteorology and climate science. It's really core. Physics is useful and important too, but maths is really the crucial one to keep studying. So the way I got into this area was that I did physics, maths and geography A-level. And then I did a gap year and went on to University of Reading, where I did a degree in meteorology. And I also had a year in Oklahoma as part of that, which was fantastic. Got to try different courses out there and do some storm chasing. And then I stayed.
That wasn't strictly part of the curriculum, as I remember.
No, that was extracurricular, but great fun.
But widely done, I think, and very sensibly so. Good. Well, I hope we can encourage people that meteorology is a fantastic career. You get to experience the world around you. And just linking back to Edward Jenner, I think the importance of Jenner was that he was someone who observed the world around him and was, I mean, the natural world, the cuckoo, birds, migration, quite apart from what he's famous for. So if you study the world around you, then a lot of things can change as a result. And I think meteorology shows you that too. Thank you very much, Claire. Thank you very much, Simon, for your contributions. It's been great to talk to you and have your insights into these cloudscapes that people have offered us. So thanks very much. And I'll pass you back to Owen at the museum.
Thank you, Giles. I'm trying to start my video. It won't let me. Here we go. So thank you, Giles, and thank you very much to Dr. Claire Ryder and to Simon King for taking a look at some of the photos that have been sent in. And we hope it's interesting for me to realise that what makes an interesting photo isn't necessarily an interesting cloud photo. So we've had some fun looking through, trying to find some fog pictures at the end and other optics that Kezia and I were able to find on our phones. So not all of those pictures were taken this week. I'm afraid I might have tricked you a little bit there, but thank you very much for sharing your time with us, sharing your thoughts, and thank you very much to everyone who has joined in and sent in their photos and taken part in not just today's discussion but the whole weekend. It's been a whole weekend of different science-related activities, all of which will be available in due course on our website at jennermuseum.com/Discovery Day, so you can go on and catch up with anything you've missed. And we've had everything from immunology to meteorology to pathology and oh gosh, so much that it's all a scientific blur at the moment. So Dr. Jenner's house is owned and run by the Jenner Trust. We are an independent charity. Our work is to celebrate the life and legacy of Edward Jenner, a pioneer of vaccination, but also one of the just the most interesting scientists. I think Giles hinted at some of his meteorology interests, but also he was a medic. He was an accomplished musician. I mean, just so many different things and so many different discoveries. And we very much want people to see the world as Edward Jenner did, to try and think a bit more scientifically and to kind of have the conversations with each other that might just go on and change the world and improve our understanding of just how everything around us works. And that's very much what we try and do, is to encourage people into science, but also to celebrate Jenner's legacy and continue promoting vaccination, of course. If you're interested in our work and want to find out more, please do visit jennermuseum.com. And the other thing I'd say is that we are an independent charity. Everything that we've offered this weekend has been free of charge. But if you are able to make a contribution, any donations will be gratefully received, and all of those will be invested in our work to keep the museum open to the public and to keep doing this. As you might imagine, we're all having a very difficult time at the moment. We rely on visitors for about 70% of our income, and at the moment we have no visitors and are unlikely to be able to open until the spring. So times are hard for us, as they are for small charities and businesses and people up and down the country. If you are able to make even a small contribution, it would be very much appreciated. Thank you once again for joining us, and thank you very much again to Dr. Claire Ryder, to Simon King, and to Professor Giles Harrison. Thank you for your time.